We can also do definite integrals with our exponentials, so all the rules stay the same as we had before, still integrate the same way and do the same notation. This time we're integrating e to the x, so the integral of e to the x is e to the x between 1 and minus 1. So we put in 1, e to the power of 1 is just e to the, we can leave it like that, minus e to the minus 1, and we can put that in there. So the rules stay the same, we integrate exactly the same, we just doing with exponentials. E to the 2x between 0 and 2, well, integrating gives us a half e to the 2x between 0 and 2, so we put in 2, 2 2's are 4, so we get half e to the 4 minus a half e to the 2 times 0, which is e to the power of 0. Now be careful, e to the power of 0 is 1, so we've got to be really careful not to go e to the power of 0 is 0 and get rid of it. So it's a bit different to our polynomials, we've got to take a little bit more care. And that will just give us a half times 1, which gives us a half there. So be really careful about it. See here, we're going from minus 1 to 3 of e to the minus a half x, which we integrate gives us minus 2 e to the minus half x. So we're going to substitute 3 in, so it gives us 3 over 2. And then we're going to subtract minus 2 e to the half, so because we put minus 1 in, it becomes positive a half. There, so because that's going to be negative times negative gives us a positive, we're going to put it out the front, 2e to the half, and the minus e to the minus 3 on 2 is just going to be put there. So we can leave it in that form. You can put it as a decimal if you like, but you don't necessarily need to. Leave it in exact form, it's probably easier. E to the power of 1.5 over t, that times t, between 0 and 1 gives us the 1 over 1.5, which is 2/3. And e to the 1.5x stays the same. Between 0 and 1, so we substitute 1 in, that will just give us 1.5 and 2/3 of that, and then minus 2/3 times e to the power of 0. Remember, e to the power of 0 is 1, so that's why it's just minus 2/3 at the end, and that one's just stayed the same there. In question E, we're going from minus 0.5 to 0.5. E to the minus 2x, integral there would be 1 on minus 2, e to the minus 2t. So integrate between minus 0.5 and 0.5, put 0.5 in, gives us 2 times 0.5 is minus 1, half times e to the minus 1, well that would be 1 on 2e, because e can go down the bottom there, because that's the power of 1, well it's a fraction, it would be minus 1. This is going to be minus a half of e to the power of 1 now, because when you put minus a half in to that part, it gives you positive 1. So that's why it gives you a positive a half e, which we're going to leave out the front there. And the last one here, e to the power of minus 3u, between minus 1 and 0. Again, derivative integral would be minus 1 over the a value, which is minus 3. E to the power of minus 3u, put 0 in, that's going to be 1. So that's where we get the minus 1/3 from in that part. Then plus 1/3 e to the 3, because put minus 1 in, that's going to give you a positive 3. Once you've done that, and the negative times the negative gives you the positive out the front. So just taking a lot of care with the signs, a lot of care with the indices, and hopefully we're able to get the right answer.